Hi folks, this is question 9a on page 98, and they give us the scalar equation of a line, and they ask us to find the vector, parametric, and symmetric forms of this line. Okay, so again, to find those versions of the line, we need a point, okay, or a vector to a given point on the line, and we need a direction vector. Okay, so first things first, let's try to find a point on the line. So we know we can find a point on a line given in this form by replacing x by a value and then solving for y, or the other way around, choosing a y, solving for x. So I'll choose an x value, and I want to choose something that will hopefully give me a y value that's not fractional. Here I see a negative 3y and a 15, so I know that if I make x equals 0, okay, I'll be left with something that's easy to solve. So if x equals 0, I get negative 3y equals negative 15, so y is equal to negative 5. So a vector from the origin to a point on the line is given by, and of course that should be positive 5, okay, is given by 0, 5. Okay, so a bit of work to do to find a point on the line. Now let's find a direction vector. So again, a trick I've used a few times is I know that a normal vector to the line that I'm given is given by the a and b values, so 5 and negative 3. And I can use that to find a vector perpendicular, which would be a direction vector for this line, by just reversing the x and y components and making one of them negative. So I'm going to make the negative 3 negative, in other words, turn it into a positive to get 3 and 5. So let's just keep in mind why that works, because if n is normal to the line, then a vector that is perpendicular to the normal will be parallel to the line. So this will work as a direction vector. And so now I have enough information to write out the vector equation of the line. So we know that it's the vector to the given point, in this case here 0, 5, plus some parameter times the direction vector. Okay, if I now want to write it in parametric form, remember that this r here is just representing some general point on the line. So if I want to write it in, so this is vector form. If I want to write it in parametric form, I'm just splitting up the expression or the equation into two separate parts. One for the x component. Okay, so I just add up the x components of the right hand side. So 0 plus 3 times t. So that just gives me 3t. And then I'm writing out the y components, which would be 5 plus 5 times t. So 5 plus 5t. Okay, and this would give me the parametric form. Okay, and then finally we have symmetric form, which is written as a pair of ratios, and the ratios are x minus the x component of the given point, which in this case here is 0, so x minus 0 is just x, divided by the x component of the direction vector, in this case 3, and that's going to be equal to y minus the y component of the given point, in this case here 5, so y minus 5, divided by the y component of the direction vector, which in this case here is 5. And so this is the symmetric form of the line. Okay, and that is it.